And now the moment we've all been waiting for, the debut of the Sonex Highwing. So the start, well, not even the start of AirVenture 2024 over here at the Sonex grounds, and every year they have these homecoming open houses where Mark can show off his offerings, and something that's been very, we've been all waiting for this, is what's sitting behind us here, and that's the Highwing. So Mark, you want to officially introduce the Highwing to us today?
Of course, Brian. Yeah, long awaited the Sonex Highwing. I've been working on this design for, I was trying to remember, I think about 7 years in total, and it is the next evolution of our series of designs.
So Mark, you announced this about 2 years ago.
Yep.
Hoping
Three, I think.
Was it 3?
The same year that Vans introduced their Highwing.
Okay, so you introduced this 2 or 3 years ago, and today we finally have something to look at. What was some of the hurdles you guys had to go through in the design from going from a low wing, I call it a bathtub style airplane, to a high wing cantilever?
It was designed from a clean sheet, obviously, so it wasn't so much a matter of converting, but the things that were really important in the design were the torsional box units in the fuselage. Doing a large door, which was very important to me as far as accessibility to the airplane, and so just making sure that all of that structure is adequate, more than adequate, to still be an aerobatic airplane, and just as stout as ever. And that was really probably more effort went into the fuselage certainly than it did the wings, because the wings are not much different in terms of how you design them. Of course, they're purpose built for this airplane, but the fuselage.
So at first glance, looking at this, you would think that maybe several components are shared amongst the different models,
right.
But this is not. This is a clean sheet design that just has the appearance of your other line.
Just like people ask us if you can build our jet from a YX,
right?
Same construction techniques and materials, and that's where you get that similar look, obviously in the same design philosophy in a lot of ways.
So it has a look and feel of every other Sonex that you've made, but dimensionally, everything is new.
Yeah, it is a larger airplane. Max gross is 1,500 pounds at utility category, 1,230 pounds aerobatic, meaning that you can actually do aerobatics with 2 people on board. So it's our first aerobatic approved aerobatic category airplane with 2 people. And our empty weight goals are about 800 to 820 pounds. We'll see how we do there. Yeah. So far it's going really well. Actually, we weighed it this morning in terms of where this phase that's at now, obviously not complete yet.
Sure.
And we're right on target for weight. So
going from the low wing to now the high wing, and it's essentially a cantilever wing anyway as a low. Yep. What kind of hurdles do you have to go through to be able to attach the airplane to the wing now being above and still be a cantilever?
Yeah, so very important for it to be a cantilevered wing. We want it to be fast and we want it to be aerobatic, just like a Sonex. So we're mounting the wing up high, and so the entire fuselage structure for the fuselage sidewalls, and that all has to create a unit, and has to be braced appropriately for again a torsional box or a series of torsional boxes, and the seat is very low, It's not like we have a very thick floor deck.
Yeah.
But you'll notice we actually do have a floor deck behind the seat into the instrument or into the baggage compartment, and that all helps to box the fuselage out structurally. Also, we have the center tunnels between the seats, which is also a key structural element in the design.
So let's step over to the fuselage here and get a little bit more of an in-depth look at the details of the construction. And then you and I will sit in this, because that's the other big selling point of this, is there is so much room, even shoulder to shoulder in this aircraft. So let's go talk about the wing first.
All right.
But first, how about a little taxi test action? Without rudder pedals.
I did start it before you started talking. Now you can go.
You got to start over. Is it running?
It's running.
This is the official, unofficial first taxi test. But don't judge me because I don't have any rudder pedals. All right, let's go.
There you have it, folks.
All right, I'm gonna pop in here real quick to talk about our sponsors. As you know, I can't do this all on my own. We got to have somebody to help fuel that truck. We try really hard to work with sponsors that provide a good service and a good quality product. So let's talk about those guys right now. Dynon Avionics at Dynon.com, the premier provider of glass panel avionics systems for experimental and light sport aircraft. Wide Open Door Company at WideOpenDoorCo.com, your premier destination for high-quality doors, including aircraft hangar doors. Warp Drive Propellers at WarpDriveInc.com, providing quality, solid carbon fiber propellers for many light sport and experimental aircraft. And visit our website at ExperimentalAircraftChannel.com for new videos and easy-to-navigate playlists and so much more. Speaking of fueling that truck, if you guys want to join us on our Patreon page, become patrons of this channel, just search on Patreon for Experimental Aircraft Channel. Sign up at several different levels, so check that out. All right, so moving into the inside of the aircraft now, and I'll get some B-roll flying around here so you can see all the details, but I wanted to jump in because this is really the selling point of this aircraft, I think, other than it looks really cool, is how much it's a real airplane.
Well, they're all real airplanes, Brian. But this is definitely designed to have more utility than anything that we sold before. We just get a lot of demand from people that want to put two average to large size people.
And that being said, I'm unfortunately currently about 215 pounds, and you are about what right now?
200.
Okay, so we're both over 200 pounds. We're not even touching shoulders right now.
I'm not leaning. I mean, I'm within the door.
Yeah. We're not staggered. The seat, one seat isn't forward or back. We're at the same level here.
Right.
My legs, I can completely stretch out, so it's roomy.
Yeah, we don't have rudder pedals in it yet, but basically the bottom of the firewall, maybe an inch forward, is neutral for rudder pedals. So basically what we did is we gave it, the proportions of the airplane are bigger, so it's more span. It's 26.2 foot span versus 22 in the Sonex. So, you know, because of that, the tail has to get longer and the surface is bigger and all of that.
Sure. That being said, though, you said the frontal area, the area that the wind sees, which starts at the cowling of the spinner, is not the same. This shares the same firewall
as the B models.
As the B model.
B model cowling and firewall.
Okay, which is great for you for production and parts making.
But we also, we want to obviously minimize the drag, and it is a bigger airplane. It'll take, to match apples to apples performance. It'll take a little bit more horsepower, but not a whole lot more. So
you're still factoring in what range as far as the horsepower goes?
Yeah. So I mean, depends on what engine you have and what you can burn and what you can true out at and what you can burn in cruise. So you should be able to do with 30 gallons on board. You're going to be able to do. I hate to speculate at this point, but it's something in the 500 to 600 mile range or more.
And this will be able to accommodate like a 100 horsepower to 150 horsepower engine.
Yeah, the UL Power 130 horse engine is what we going to have in this prototype. We're going to be doing RPM, power tests at various RPM settings to simulate smaller engines, and so we'll be able to do VX and VY tests testing all the way down to 80 horsepower. So we'll see even how the normally aspirated Aero-V will do.
Sure.
Keep in mind, we fly the 80 horse Aero-V in the Xenos, which is our biggest airplane, but it's got a lot of wing.
A lot of wing.
So we'll see how it does, but we want to know, you know, what you can put in the airplane. I'm expecting it'll be 100 horse and up.
Okay.
But we'll see what it'll do on 80.
Awesome. Well, going back into the cockpit here, obviously we've got a very wide real estate here.
Yep.
So lots of room for pretty much anything you want.
Yep.
And I'm sure that was on purpose.
Yep.
There's a lot, I see new, obviously, machined parts to be able to accommodate the build.
Yeah.
And how would you just take it percentage-wise compared to your other ones, that there's more?
There's a couple of more machine parts. They're about roughly the same number, just different as the B models. You know, obviously, yeah, the wing attach fittings are. This is what holds the spar on the airplane. It's a very important part. You know, you look at the shape of the door and the spar. So you picture in terms of how the airplane has to be designed to do that. The easiest way to explain it conceptually is imagine when you're on a ski lift and you look at that bar that goes around up to the cable. It's the same concept.
Gotcha.
As far as the way that the structure has to be stiffened and everything.
And it appears you pay a lot of attention to the real space requirements here. I'm 6 foot tall.
Yep.
I'm sitting on a decent 2 or 3 inch cushion.
Yep.
I don't have a headset on, but there's plenty of room.
Yeah.
Here. I'm not going to hit my head on the headset moving around or whatnot.
Right. Yeah. And that's the thing, is that, you know, we didn't want it to be where even just sight line wise, where the wing is at your eyes.
Sure.
So, you know, it was important to us to get the seat as low as possible, and somebody who's shorter can just do a thicker cushion.
So I wanted to come back to the turtle deck and where the center section joins in, just talk about this here, because this is kind of busy, if you will, right? This is a lot of stuff going on here.
Yep.
I do like very much that you guys decided to engineer in a skylight.
Yep.
Bring some more light into the cockpit, and then the side windows.
Windows.
Just the styling it's pretty cool too.
Yeah.
But talk to me about the need for a center section as it goes with the cantilevered wing.
Right. So it's very important to us to have removable wing sections, because you're going to more than likely be building this in the garage, and how you're going to get it to the airport.
Okay.
You know, we talked about a fully removable wing, but that gets really difficult in terms of sealing everything up and making all that work, and it's something you definitely wouldn't want to do again.
Sure.
So instead we went with the concept that we do for the jets. So we have a center section wing, and then we have outboard panels that attach to it.
And this aircraft is a push-pull tube system, no wires.
Right.
Which makes it easier to disassemble.
Cables will be for the rudder, just like our other airplanes.
Okay.
Yeah. So we designed it with a center section spar. There'll be machined tie fittings that get bolted in on the top and the bottom into the spar caps, just like the jets. And so it's not a 20-minute job. It'll be about an hour to put the wings on or take them off.
And everything that's doing anything for the aircraft is basically inside these dimensions here. You got another, we'll talk about that for a second. You've got a auxiliary tank.
Yep, we have 5 gallons on each side of aux fuel. So we have the 20-gallon B model fuel tank in the nose, header tank, and then we have 10 additional gallons of aux fuel, which you could just turn the valve up by your head and gravity feed it in. Sure. So we can have, you can take up to 30 gallons of fuel. The aileron push rods are actually going to be in the aft portion here. We don't have it cut yet, there'll be an access panel so that your push rod from the outboard will come through the lightning hole here, and there'll be an idler belt crank that we'll disconnect those.
So essentially, if you wanted to remove the wings to transport to and from the airport or for storage or whatever, because everything is central to the aircraft, the only thing you disconnect is if you have wiring for lights, and then one of your push-pull for your, two ailerons and flaps.
Right. Well, the flaps actually will just be pinned. So basically, the flap, you see this funky cutout, this is the flap torque tube. The flaps will connect here. There'll be, of course, be a nice fairing in the back here. In this area. the flaps will go out to here, and then the outboard flaps, they'll just be shear pins. So they just insert, they just slide right in. So there's no hardware to disconnect, to disconnect and remove the flaps.
Very nice.
So you just disconnect the ailerons at this point, obviously unbolt the wings, any wiring, and take it out. This will have a cuff strip. Okay, so
just to be able to, for the mating pieces
right
there, yeah.
So unlike our other airplanes where we have a big 063 plate on each the outboard and the inboard wing root, and heavier machined fittings at the joint, in order to make the assembly lighter, we did, added a few screws that you'll have to remove, but there'll be a cuff strip. And what that does versus the machine fittings is takes all transfers the torsional loads from the outboard skin to the inboard skin.
Okay.
Otherwise, with on the jets, for instance, we have the heavy root rib fairing fittings, and all that is it takes the skin loads, dumps them into the spar, and then from the spar at the joint, it goes back into the skins.
Yeah, which people I don't think realize how much is going on there. Like you talk about a typical, I don't know, as a Cub or like an aircraft that has two struts.
Right.
You're connecting to the front spar and the trailing spar for that, and then you go to aircraft design that have the single wing strut.
Right.
That usually goes to the main spar. You have to take that torque loads. Now you don't have anything there.
Right.
So you have to take the torque loads.
In a sense, a cantilevered wing, especially because that's where all of our experience lies, is a much simpler thing for us to design. There's, a strut-braced wing is, takes a lot of other things into account, especially at the bottom of the fuselage. So,
I'm sure, like in the rigging process, that kind of makes it a little easier.
Oh yeah.
Versus trying to triangulate.
For sure.
So
Yeah,
much
and
more going on.
this airplane will be essentially self-rigging when you build it. You'll be making sure that things are square,
right,
so that you aren't building a twist into your wing.
Because that's all determined right here anyway.
Yeah, everything's just locked in.
So, and you would build the center section on a table, and then
it's really built on the airplane.
It's built on the airplane in place.
Yeah.
Okay.
So you'll be spending some time on step ladders.
Yeah.
Up there. Yeah.
So one thing I wanted to point out as well, having the access of this skylight or sunroof, whatever you want to call it, I'm sure some people want to know, can you adapt a parachute into this and have that eject?
Yes, absolutely. So that is a part of the design mission of the airplane, to be able to do a BRS, and you'll just have your cables, with breakaway fairings going up to the main spar, and probably at the major vertical member here for the rear.
So fun fact real quick, I pointed out to Mark when I first got you can't miss his new blue shoes. And it's kind of a thing, at least for me and apparently for Mark, every Oshkosh, you have to go to the store and buy a brand new pair of shoes because we walk so much here. So.
Yes. Well, we've been so busy working on this that my wife actually dragged me to the shoe store last week and said, "You need new shoes."
I should have got a red pair because they really stand out.
Yeah, right.
Anyway, let's talk about the airplanes again. So back to the firewall here. One thing, again, probably the only thing. So back to the firewall, probably the only thing that is shared amongst the different designs is this firewall. Is that correct?
Yeah, pretty much. The firewall and the cowling are B model, and of course the fuel tank, the header, the fuel tank in the nose is the same 20-gallon B model fuel tank, and so that was very important. The motor mounts are slightly different because we do have a slightly larger diameter gear leg
to accommodate the weight.
To accommodate the higher gross weight.
Okay.
Yeah.
Now this one is being built around the UL Power 130 horsepower as your test mule.
Yeah.
Which other engines are you preparing for?
So the 9 Series Rotaxes, it will have a ring mount for people that want to do the turbocharged Rotaxes instead of the bed mount that we currently do on the other airplanes now. The Jabber 3300, Aero V Turbo, and we'll see, based on our climb testing, whether we think the 80 horse Aero V would be acceptable as well.
Okay. Well, good. Those are some really good options, and I think coming out of the box with 130 horsepower, this is going to be a real performer.
Oh yeah, that's our hope, and we're hoping to be in the same neighborhood as far as cruise speeds as we are with the Jabber-powered Sonex. I mean, we might not be quite as fast. We have 10 more horsepower though, so we'll see what it does.
So, all right, this is obviously your first sort of debut, soft debut of this design in the flesh, in the real,
in physical form.
When do you think, in reality, because you got wings left and some polishing, tweaking of some stuff, when could we possibly order one of these kits in the near future?
Well, we want to get it flying. We might do pre-orders just to get in line. They'd be very inexpensive if we did that, like $100, like Cybertruck deposits.
Interest and for production,
just to help us
up.
Get a sense of the numbers.
Yeah.
And we may do that this fall. We'll see how much closer we get to being ready to fly before we do that, and what kind of progress we're making.
Okay.
But it's really, of course, hard to nail down a time frame on a new R&D project, especially when you're busy satisfying existing customers.
We got work coming out the door already.
But certainly, you know, we really want to have be taking full kit orders next year, and you know, hopefully shipping inventory at some point next year.
So guys, Mark's informed me, unfortunately, well actually, fortunately, this is the right way of doing business in my opinion, is he doesn't want to take deposits at the moment because it hasn't flown and there's still some things to be done. So unless you want to throw money at him just because you like him, he's not going to take any deposits just yet. So,
and of course we are designing this for the Mosaic regulations that are coming to be light sport aircraft compliant, and we are doing that with ELSA and SLSA production in mind, in addition to experimental amateur built kits.
So do you feel that's finally really going to happen? Because I feel like we've been teased for years.
Yeah, so since the NPRM came out and the comment period closed, the FAA had a very brief window because of other administrative things going on where they were actually allowed to talk about it. Normally after an NPRM comment period, they're not allowed to talk about it. So for a brief window, they were able to give EAA some feedback, and it was all very favorable, including the comments that came in. So we feel like 2025 will have the new rule. That seems to be what the consensus is from everyone. And the airplane, this airplane as it is, will fit the NPRM. So we don't even need some of the expansions that people have suggested in terms of stall speed.
You've gone ahead and designing around the mission for that.
Right. So I mean, obviously we want it to still stall as slow as possible, you know, despite the extra gross weight. So we're well within the NPRM proposed stall speed, and so yeah, we're really excited for that, and we'll see. So yeah, if somebody wants to you know, hand us some money to do the SLSA production thing, but otherwise, as far as kit builders, I'm not ready to take deposits yet.
Okay. Another thing that people always ask, and actually kind of beat me up online, is not asking the price, and I do ask the price.
Yeah.
But most often people don't want to share that, and you're not quite ready to do that, but you want to stay somewhere with the Xenos price
we'll
point.
be in the neighborhood, as far as I can tell, for the Xenos kit price. So we'll be in the high 30s in today's dollar. We'll see what tomorrow's dollar is. But that's what I think I've thought for a long time, based on the parts and the size of the airplane, where we'll be.
Awesome. Okay, well, if you are brand new to the channel, welcome. If you're brand new to Sonex, welcome. And where can they follow you on social and anywhere else that you're posting updates on this and other projects?
Yeah, so SonexAircraft.com. We're on Facebook, we're on X now, not Twitter, Instagram, and here at Oshkosh in the home build area.
And this is the start, actually tomorrow is the start of Oshkosh. I may try to get this edited this afternoon. We'll see if that happens. But if you're watching this over the weekend, come out to Oshkosh this week. This will be on display in the booth, out in the major section of the home built section. And they're inviting everybody to sit in it so you can try it on for size. Yeah,
absolutely. This is a drastic change from what you thought Sonex was or ever could be. So as far as cockpit and comfort and everything. So we're really excited.
We look forward to the first flights.
Yeah. All right.